Welcome to the Calculus, a collection of micro lectures, video lessons, and sample exercises. Let us prove the differentiation rule for cotangent trigonometric function. Now here we are going to show the proof that the derivative of this trigonometric function cotangent x is just equal to negative cosecant x squared. Okay, this is actually can be written as negative of cosecant squared x. Okay, so just like that. So we are going to use here the relationship of cotangent in terms of sine or cosine. We will no longer use here the definition, so please bear with me as I will use here the quotient rule, or the rule in differentiating a quotient or rational function, because we can rewrite this, say for example in this manner: f of x is cotangent x. We are looking for its derivative, so cotangent can be written as cosine x over sine x. This being a ratio or a quotient, we can use here the rule for quotient in this manner: if f of x is equal to k of x over m of x, where m of x is not equal to 0, its first derivative is this. In exact order, it cannot be interchanged. You have here the denominator times the derivative of your numerator minus your numerator times the derivative of your denominator, all over, sorry for that, let me make this later, all over the square of whatever function you can see on your denominator. So just like this here, we can use that to represent the derivative of cotangent x, and see after this process if it will really yield negative of cosecant squared x. Before we proceed to the proof process, we may use this, as this is already identified as equivalent to this, so we can say that k of x is the numerator cosine x. Its first derivative is actually negative sine x. We already have proven this, so please try to review some of those videos. As for our denominator, m of x being sine x, its first derivative is actually cosine, positive cosine x. Make sure that you will not be interchanging possible results as well as this idea here. So let's look into this. As mentioned, let's move it down. Again, we can use cosine and sine, right? So we can have here f prime of x. We will be using a denominator, in this case again m. M here is sine x times the first derivative of your numerator, this one here, negative sine x. Let me move this a little bit lower. Okay, then minus, take note it's minus here, minus, it's minus your numerator cosine x times, I'm using this parenthesis by the way, I'll be using this to really separate the angle from the trigonometric function, and then times the derivative of your denominator, another cosine x, all over the square of your denominator here, which is again sine x. So sine x, the square of that. Simplifying this, you have negative times positive. You have negative sine squared x. You also have negative cosine squared x over the square of sine x. Now, what if we will factor negative 1 from all the terms here? So negative 1, you will have positive sine squared x. Instead of negative, you will have positive cosine squared x all over sine squared x. What is this equal to? This is one of the trigonometric identities where, as long as it is on the same angle, the square of sine plus the square of cosine is just equal to 1. Hence, negative 1 times 1, numerator will still be negative 1. Again, I'm writing it here. Sine squared x plus cosine squared x, as long as they have the same angle, they can be interchanged because this is addition. This will always be equal to 1. That's why we have here negative 1 times 1 over sine squared x. Okay, if we are going to take negative here, 1 over sine squared x, what is this equivalent to? This is actually the reciprocal of sine, and that means it is actually cosecant squared x squared, because this is squared in the first place. Take note, it has a negative sign, so negative square of cosecant x. This is already what we are trying to show for this video, that from cotangent x, if we are going to use cosine over sine as its equivalent and solve for its derivative, you will get a result of negative cosecant squared x. Hence, therefore, the derivative of cotangent x is equal to negative cosecant squared x. Okay, this is the end of this proof. By the way, I wasn't able to place here the term proof. Okay, thank you very much for watching. So what are you waiting for? Subscribe now.